Hello everyone, welcome to the channel Physik. I am Anik Panda. I will be teaching this course on classical mechanics, and this one is my first video that I am making, and I will be covering topics from fundamental and basic levels of classical mechanics, from Newtonian to Hamiltonian mechanics. We will also look after the topics of various mathematical terms such as calculus of variations. At last, we will deal with relativistic mechanics and we will talk about special relativity there. So today, on our first video, I promise you that this complete playlist will be a great benefit to you, and each and every topic will be discussed, and at last various problems will also be discussed. So today, this course on classical mechanics, the first topic that I am going to discuss about, that is on the history regarding the foundation of classical mechanics. There is the historical background. It's nothing but the historical background that we need to know to start this topic. So, classical mechanics starts with the first scientist who founded classical mechanics, gave the fundamental idea of what we'll call as inertia of the body, is no one but Galileo Galilei. Galileo Galilei, he was the first one. Following him, whose ideas were modified by Isaac Newton later on, and then he founded the fundamental three laws, which are on motion, the three laws of motion, which are famous all over the world of physics. Galileo Galilei, he is the father, to be regarded, as for me, because his experiment that he performed, first experiment he performed, that was on a boat. So I am going to talk about that experiment, following which experiment he first came to know about the phenomena of inertia, that a body possesses a certain property called inertia. Then from then on, what inertia depends on, what is inertia, I will also discuss about that, and daily life applications of inertia. And then we will also talk about in this video about the mechanical state of a body, how to denote the mechanical state of a body, the trivial system, or the standard notations that we use to denote the position, momentum, or the velocity of a body in classical mechanics. I will also deal about that. So the experiment, the famous experiment performed by Galileo So here, pardon my picture. So I'm not that good in drawing pictures, but for educational purposes, I think for understanding purposes, this is good. Whatsoever, this is kind of the boat that Galileo was traveling. He was a good climber, because in this experiment, Galileo climbed up this. I marked this as the mast of the ship. He climbed up. At this point, the ship was actually traveling in a pleasant sea, without any waves or something like that. So Galileo assumed that the boat in which he was traveling was moving with uniform velocity. So the boat was, while he was traveling, he climbed up here with a ball, maybe made up of iron or something like that. He went up the mast of the ship, and he just dropped the ball just like this, just vertically downwards. It fell. He didn't threw it, he just dropped it, and it fell something like this to, I mean, somewhere here, and he marked this such point as the position where the ball fell. And he, every time he dropped the ball, he dropped it in such a way that the ball fell in that position only. But all these experiments were performed only when the ship was traveling at uniform speed with an uniform velocity. But soon then, what Galileo did was, he turned his boat and took it to another position where there was some acceleration. That means there was some waves, some thrashing waves which are making the boat to accelerate. And soon he found that while the boat was accelerating, the moment he threw the ball, it didn't fail here. So you can imagine that this is the point where the ball fell when it was traveling with a velocity v. I am giving the vector sign because it's in a particular direction. So the ball fell here, but as soon as we gave some acceleration, as soon as the boat started to accelerate, the moment the ball fell here, within that time the complete boat displaced suddenly because of the acceleration, because of the sudden acceleration, it just displaced here. So instead of falling in that position only, it fell in the sea. So this is the boat. So as soon as it was traveling uniformly, the ball fell here, but as soon as he just dropped the ball and the boat suddenly accelerated, the ball fell in the sea. So from this experiment, what he got was the property that the ball, while falling downwards, because of inertia, I am discussing about inertia now, because this experiment's purpose was to conclude that what he concluded from this experiment was that inertia only, that the ball. Now let me make you understand about inertia. While the boat was traveling at uniform velocity v, the ball fell here, but as soon as the boat accelerated, the ball didn't just moved here, it didn't just turned away and fell at the same position, but it fell in straight direction and into the sea. So the inertia of the body is just the resistance of the body to against external forces. So if this is the pen, I am giving it external force to move it in that direction. So the inertia of the body would just cause this body to remain in the place of the rest. It was at rest, so the inertia of the body would allow it to be at rest only. It would try as much hard as possible so that this pen remains at rest. So the same thing here, the ball fell in the straight direction under the influence of gravity, So the ball was not directed, or it was not ordered that you should go here, you should I mean, when the boat started to accelerate, no one ordered the ball, or none of the property of the ball ordered it to just strike the board of the accelerating boat like a rocket, but it just fell downwards. So it had no effect on the whether the boat was accelerating, or it was moving with uniform velocity. It fell on the same direction only. That means the inertia of the body is such a property that it never allows the body to, it always goes against external forces. So external force was on the system of the boat, that what caused the boat to accelerate. So, but the ball's inertia is such a property that it didn't allow the ball to fetch, to go after the boat and just fall in that position, but the inertia of the body allowed to remain in the to behave to exactly as it behaved previously, and to fall in the same direction. But unfortunately it didn't fall on the board because the boat had already passed away, so it fell on the sea only. So what I was writing, that the ball while falling downwards, because of inertia, it didn't go after the boat or the position of the board as directed above. So this is only the conclusion that he came, that what prevented. So the question we will ask ourselves, that what prevents the ball to just just fall on the same position while the boat was accelerating. If such question, if you ask yourself such question, then you can answer yourself that this was the property, the inertia, the fundamental property that we are discussing so long. This is what allowed the body to just continue in its straight direction. It didn't just, you have just focus on my pen. Imagine this pen is the ball, and this page is the boat. Until and unless the boat was traveling at uniform velocity, it fell in this position. But suddenly this boat moved, but because of the inertia only, it just fell downwards straightly. It didn't just went after it and just fell here. That is what I wrote here, that the ball, while falling downwards because of inertia, it didn't go after the boat or the position of the boat as directed above. It prevented it from any change in its motion, mainly the state. So now let us talk about, I'll also during the last moment of my video, I'll also talk about, in this video only I'll talk about more about the property of inertia. But let me now go towards the motion. Motion is of two types: no motion and motion. These can be stated as the two states of a body. No motion means, we can, from common sense we can know that it's at rest, and motion means it's moving with respect to time, obviously. So if anything moves with respect to time, we can say that it's in motion, obviously. And if something is at rest with respect to time, we can also say that rest with respect to time, that means it's not changing its position xyz, it's not changing, so it's at rest. So these are the fundamental states of a body. So state means, in physics, state of a body means the complete information. Actually, this is the simplest definition that I can give, and it will make you clear. No such hanky panky definitions. This simple definition only, no such bookish. The complete information that how the body will behave with respect to change in time. The complete information that how the body will behave with respect to time. Complete information means the parameters, you can say, which will state that how the body will behave with respect to time. That means it can be position. How position? This it is at the pain is at particular position. Now after 5 seconds, it will, what position it will be, it depends on the position only, that whether this pain will be at rest or in motion. So this position gives a complete information how the body will behave with respect to time. So how that after 5 seconds, if I see that if this pain is here at this rest position only, then I can say that the body is at rest. So it gives a complete information about the behavior of the object. So what is the behavior of the object? The object is at rest. So we can clearly say that first parameter is correct. Second is velocity. How velocity? This pen started moving. Okay, so it moved at a particular direction. So the time it's taking to move to this particular direction. Now if we move to that time and we observe the particle or here this pen, we can say about this object is behaving, that what is its behavior. Now its behavior is in motion. State are of two types, motion or no motion. So based on this velocity parameter, we can say that whether it is on motion or non-motion or no motion. This is the fundamental property of the fundamental parameter that can describe the state of the system. Another is momentum. Now to define momentum, I have to first say about mass. There had been a lot of argument about mass of a body. So I'll on the later course on relativistic mechanics, I'll discuss that mass is how Albert Einstein said about mass. But based on Newtonian mechanics, mass is what he described in his book Principia Mathematica. Mass is just the measurement about the matter present in a body. So the amount of matter that is present in a body is what we call the mass of the body. So you can see me drawing a particular I'm drawing a particular piece of object. The amount of matter or the molecules which are in this particle throughout its body. The more the number of particle on this body, the more will be the mass of this object. So the quantity of matter that is present here is the theoretical definition of mass actually. So momentum, to discuss momentum, and also another thing, the more will be the mass of the system, the more will be the inertia of the body. Let us give an example. We need more force to just move a truck. If this is a truck, suppose, if this is a truck, we need more force to move it rather than moving a just small tennis ball, because this truck has more mass than this small tennis ball. So more force means what? Its resistance power against the external force is what you known as inertia. Inertia is that only, what I just made you understand in my previous in my previous topics, that inertia is just the resistance against the external force. So the more the amount of mass this truck will be having, the more will be its inertia, and the less the mass, the less will be the inertia. So mass is directly proportional to inertia, or we can also say mass is exactly equal to inertia of the body. Mass equals inertia. So momentum means it's just a seriousness. Momentum means just how serious the motion of the object is. If it has high momentum, that means it's much serious to break something, to pass through. It can pass through something. So it's just. So let me give the theoretical definition. It's intuitive definition. It's about this quantity, seriousness about the motion of the object, which is equal to m times v. So obviously it will be a vector quantity, so I'll be denoting it by p. So p equals m times v. Here p means, as scientists denoted by p, it's a vector sign. It is a particular direction and a momentum. We all know vector. So p equals mv. So this fundamental mathematical quantity is called momentum, mass times the velocity of the object. So this gives a seriousness about the motion of the object. So obviously more the velocity, more the mass, the more will be the momentum. That means the more speed this truck will have, it can break through a wall, obviously, rather than the same velocity possessed by the tennis ball. If this truck moves at, if this truck moves at 30 meter per second, and if this tennis ball also moves at 30 meter per second, if there is a cement wall which is newly made, or maybe just 2 or 3 years old, this truck can easily break through this cement wall rather than the tennis ball. Ignoring the relativistic cases, if this moves at velocity c, that means at the speed of light, then obviously both of these can pierce through the wall. So it's a different case. It's a very complex case. I'll discuss about that later. But here, if we focus on the momentum, so what we got, that momentum equals mass times the velocity of the object. So let us just recapitulate. Motion are of two types, which are no motion and motion state. Complete information that how the body will behave. Parameters based on the state of the body, that's a position, velocity, momentum. These are the fundamental parameters which says us about the, I also said that I'll discuss about mechanical state. So this is what gives the information about the mechanical state of the body. Mechanical state means all that you can easily see that all these three parameters can easily just, this only says how the body will change its position, or the how the, this completely gives information about the motion of the body. So these three parameters just tells us how the body will change its position in future, or it may not change. We can, when in my another video, I'll discuss the three laws of motion of Newton. In that mathematical, I'll discuss about the mathematical terms related to these three parameters, and how I'll represent, how I will substitute the variables in that mathematical term, in that equation. You can easily find out in future that how, that we can easily get to know, we can unlock the mystery that whether this pen after 5 seconds, based on its fundamental parameters, that is position, velocity and momentum, whether it will be staying in rest or not. So all these three parameters are thus the mechanical property, that means relating to mechanics of the system. Mechanics, that means whether this pen will be at motion or no motion. That is these two states of the body. State means a mechanical state. So in classical mechanics there is mechanical state, in quantum mechanics there is quantum mechanical state. So there are different types of states. So let me clarify, let me be more descriptive. So it's called as mechanical state actually, because state can be of many types. So to be appropriate, this is mechanical state of the body. So this is the mass of the body, which is just the quantity of matter present in the body. And also another thing, for Newtonian mechanics, mass is constant. It's a constant, because this is my finger cannot just suddenly become thick or thin, ignoring that I don't do any exercise. So this pen cannot, ignoring the environmental changes, or the change in the atmospheric parameters, we can easily say that this pen, after 3 years or 2 years, its mass will remain almost constant. So mass is the atoms cannot just get the molecules or the atoms that which are present in the pen cannot just vanish, or it just cannot destroy. So mass can neither be created nor be destroyed. I think you might have read in chemistry about the conservation of mass. So in Newtonian mechanics, mass is constant, but if in relativistic mechanics, we'll talk later, that mass is actually not constant. It increases when the body suddenly its velocity becomes more approximate to c, that means the velocity of light, according to mass energy equivalence principle, that is E equals mc squared. So we'll deal about that later, but based on this, today our discussion was on fundamental parameters only. So today we learned up to momentum. So you just recapitulate these three parameters. So wait for my next video, that is on the three fundamental. So today I discussed about the scientist called Galileo Galilei. So our next video will be completely starting from Newtonian mechanics. That is Newtonian mechanics, that means from three fundamental laws, which are basically the foundation principles in classical mechanics, the three laws of mechanics. I'll discuss about the first law, second law, third law. So believe me that this video will be a completely beneficial to you. So within 2 or 3 classes, I'll start with then I'll jump to I'll clear all your concepts regarding this fundamental principles. Then within 5 or 6 videos you'll get to know about Lagrangian principle or Hamiltonian mechanics. So I'll also discuss some questions based on up today we learned up to momentum. So once again, channel name Physik. So that's all. I mean, that's for today. So you learned a lot, I think, so about the famous experiment by Galileo. See you next till the next video. I mean, it will be arriving soon. I mean, okay, goodbye everyone, take care. Just don't forget to subscribe this channel. I mean, if you think that this video helped you, just like this video. I'll really try to improve the camera. I mean, the camera was just manual only. Actually, I did have much knowledge, but I didn't have much materials, to be honest with you. Guys, I didn't have much materials to record, and I mean, I don't have a studio, just a manual. I just started today only. So whatsoever, I'll try my best only to. I mean, I promise you that after this lecture, I mean, you'll completely digest that classical mechanics as I have digested myself. So okay, thank you.